The levels of programming languages. Welcome to our journey through the fascinating realm of programming language levels. Today, we embark on a quest to unravel the intricacies of these linguistic layers that underpin the digital world around us. Programming language levels serve as the scaffolding upon which the edifice of software architecture is constructed. From the lofty of high-level languages to the nitty-gritty details of low-level languages, understanding these tiers is paramount for any aspiring coder. Our odyssey today is not merely an academic exercise. No, it's a practical expedition into the heart of software engineering, where the choices we make about programming languages can the destiny of our projects. By the end of our voyage, you will emerge enlightened and equipped with the knowledge to navigate the diverse landscape of programming languages with confidence and clarity. So, without further ado, let us embark on this illuminating journey into the realms of high-level, intermediate level, and low-level languages. As we delve deeper into the labyrinth of programming language levels, let us first unravel the very essence of what these levels entail. At its core, programming language levels serve as a hierarchical classification system, guiding us through the diverse landscape of coding tongues based on their relationship to machine code and hardware. These offer a structured framework, akin to a linguistic pyramid, enabling developers to grasp the nuances and capabilities of each language with precision. By organizing programming languages into distinct tiers, developers gain the ability to discern which language best aligns with the requirements and objectives of their projects. Moreover, this hierarchical arrangement empowers developers to make informed decisions regarding language selection, optimizing performance, and troubleshooting code with finesse and efficacy. Behold, the realm of high-level languages, where the complexities of machine code and hardware fade into the background, and the artistry of human-readable syntax takes center stage. High-level languages, the darlings of modern programming, are crafted with one primary objective in mind: to be easily comprehensible by the human mind. Picture a world where Python, Java, C++, and Ruby reign supreme, offering refuge to programmers weary of wrestling with the intricacies of binary and assembly code. Within this utopia of code, certain characteristics define the essence of high-level languages. Firstly, there's readability. The syntax is the cadence of natural language, paving the way for programmers to express their ideas with clarity and elegance. Then, there's abstraction. High-level languages shield developers from the gritty details of hardware operations, allowing them to focus their energies on problem-solving rather than resource management. Readability emerges as another hallmark, as programs written in high-level languages transcend the confines of platforms, thanks to the magic of compilers and interpreters. In the realm of high-level languages, rapid development, prototyping, and the construction of intricate software systems flourish without the burden of delving into the depths of low-level intricacy. As we journey deeper into the labyrinth of programming language levels, we encounter the enigmatic realm of intermediate-level languages, also known as the bridge between high-level and low-level tongues. Picture a landscape where languages like C and Pascal hold sway, offering a delicate balance between abstraction and control. In this zone of coding, certain characteristics define the essence of intermediate-level languages. Firstly, there's direct memory manipulation. Here, developers wield greater control over memory management compared to their high-level counterparts, enabling the efficient utilization of resources with surgical precision. Then there's access to system-level functionalities. Intermediate-level languages open the gates to the realm of system calls and low-level operations, granting developers a passport to the inner workings of the machine while maintaining a semblance of abstraction. However, it's essential to note that intermediate-level languages dwell in the twilight, offering less abstraction than their high-level brethren. Here, developers must venture deeper into the labyrinth of computer architecture and memory management, wielding knowledge as their guiding light. Intermediate-level languages find their niche in the world of system programming, device drivers, and applications that demand a delicate balance between performance and abstraction. As we descend further into the depths of the programming language hierarchy, we arrive at the austere domain of low-level languages, where the bonds between code and machine are forged with unyielding strength. Here, amidst the binary whispers and electronic murmurs, low-level languages stand as the bedrock upon which the digital universe is built. Within this realm, we encounter the venerable assembly language, a language of raw power and unparalleled proximity to the hardware it serves. Let us delve into the defining characteristics of low-level languages and illuminate their essence within the pantheon of programming. Firstly, there's a direct correspondence to machine intelligence. Low-level languages eschew the trappings of abstraction, utilizing mnemonics and symbols to encode instructions directly into the fabric of the machine. Then, there's minimal abstraction. In the world of low-level languages, developers traverse the bare landscape of hardware resources with unfettered access, unencumbered by the layers of abstraction that cloak higher-level tongues. However, this unfettered access comes at a cost. Low-level languages are inherently platform-specific, shackled to the architecture of the hardware they serve. Programs crafted in these languages may require meticulous modification to traverse the diverse terrain of different platforms. In the realm of low-level languages, developers wield the scepter of control over hardware resources with unparalleled mastery. Yet, this dominion demands a profound understanding of computer architecture and comes at the price of portability, contrasting sharply with the higher-level languages that adorn the realms above. As we reach the nadir of the programming language hierarchy, we encounter the primordial essence of computation itself, the enigmatic domain of machine code. Here, amidst the binary symphony of zeros and ones, machine code reigns supreme as the lingua franca of the Silicon realm. Let us unravel the defining characteristics of code and peer into the inner workings of the digital enigma that underpins the very essence of computing. Firstly, there's the binary representation. Machine code manifests as sequences of binary digits, where each pulse of electricity carries the weight of an individual instruction, shaping the destiny of computation itself. Then, there's the processor-specific nature of machine code. Like a tailor-made garment, each strand of binary brilliance is intricately woven to suit the architecture of the processor for which it was crafted, ensuring seamless compatibility and optimal performance. However, machine code exists in a realm beyond the grasp of human comprehension. Its instructions, shrouded in the mystique of binary mysticism, remain inscrutable to the untrained eye, crafted by compilers and assemblers in a symphony of digital craftsmanship. Yet, amidst this veil of abstraction, machine code holds the keys to the kingdom of computation, wielding unparalleled control over the operation of the CPU and other hardware components, orchestrating the dance of electrons with unyielding precision. As we ascend from the depths of machine code, we arrive at the gateway to the realm of human-readable low-level languages, the illustrious domain of assembly language. Here, amidst the tapestry of mnemonic magic, programmers wield the power of abstraction without sacrificing the intimate control over hardware resources. Let us unravel the defining characteristics of assembly language and bask in the glow of its symbiotic relationship with machine code. Firstly, there are the mnemonics for instructions. In assembly language, programmers navigate the labyrinth of computation using short, descriptive labels, mnemonics, that serve as beacons of clarity amidst binary fog. Then, there's the one-to-one correspondence with machine code. Each stroke of the assembler's pen finds its counterpart in the binary symphony of machine instructions, forging a direct link between human intent and machine action. Yet, like its predecessor, assembly language remains tethered to the confines of hardware architecture. Programs crafted in assembly language bear the stamp of their origins, requiring delicate modification to traverse the diverse terrain of different platforms. Nevertheless, assembly language emerges as a beacon of comprehension in the sea of machine code, offering programmers a more readable and understandable alternative without sacrificing the granular control over hardware resources. As our journey through the diverse landscape of programming language levels draws to a close, let us pause to compare and contrast the virtues of high-level and low-level languages. In this grand tableau of coding, we witness a symphony of contrasts, where readability, reliability, execution speed, and portability emerge as guiding stars that illuminate the path of programming prowess. Let us delve into the heart of this comparison and glean insights into the essence of each language level. Firstly, readability, a cornerstone of effective communication in the realm of code. High-level languages, with their human-readable syntax, offer a degree of clarity and comprehension, fostering an environment where understanding and writing code becomes a joyous endeavor. Conversely, low-level languages, with their reliance on mnemonics and direct representation of machine instructions, offer a more cryptic landscape, where the mastery of symbols unlocks the secrets of the machine. Next, we venture into the realm of readability, the ability to express our thoughts and ideas with fluency and finesse. High-level languages, with their higher level of abstraction, beckon us to the realms of rapid development, where the pace of innovation knows no bounds. However, in the shadowy depths of low-level languages, and unfolds at a more measured pace, requiring meticulous attention to detail and a deep understanding of hardware intricacies. Moving onwards, we confront the specter of reliability, the bedrock upon which the edifice of software stability is built. High-level languages, with their built-in error handling and abstraction from hardware, stand as bastions of reliability, shielding us from the vagaries of system intricacies. Yet, in the unforgiving crucible of low-level languages, the margin for error narrows, demanding unwavering vigilance and meticulous attention to detail lest the specter of failure looms large. As we gaze into the abyss of execution, we witness the dance of performance unfold before our eyes. High-level languages, with their layers of abstraction and translation, may find themselves outpaced by their low-level counterparts, whose proximity to machine code grants them swiftness of execution unparalleled. And finally, we confront the challenge of portability, the ability of code to traverse the vast expanse of computing landscapes with ease. High-level languages, with their translational prowess and platform-agnostic nature, navigate the seas of portability with grace and finesse. Yet, in the shadows of low-level languages, the specter of platform specificity looms large, modifications and adjustments to traverse the diverse terrain of computing platforms. As we stand at the crossroads of programming language choice, it's imperative to weigh the advantages and disadvantages of each linguistic realm. Let us embark on a journey of discernment, navigating the treacherous waters of pros and cons. Firstly, let us extol the virtues of high-level languages, where readability, productivity, portability, and reliability reign supreme. High-level languages, with their syntax akin to natural language, offer a sanctuary of clarity and comprehension, fostering maintainability and ease of understanding. Furthermore, the productivity gains afforded by higher-level abstractions and built-in libraries propel development into the realms of rapid innovation and creativity. Portability emerges as another cornerstone, as code crafted in high-level languages traverses the diverse landscape of computing platforms with ease, thanks to the magic of translation. And let us not forget the mantle of reliability, where built-in error handling and memory management shield us from the specter of bugs and crashes, ensuring the stability of our digital creations. However, amidst the splendor of high-level languages, shadows linger, shadows cast by the specters of execution speed, limited control, and resource consumption. High-level languages, with their layers of abstraction, may find themselves outpaced by their low-level counterparts, sacrificing execution speed on the altar of readability and productivity. Furthermore, the siren call of direct control over hardware resources beckons from the depths of low-level languages, enticing programmers with promises of fine-grained optimization and platform-specific performance. Yet, in the labyrinthine corridors of low-level languages, complexity lurks, demanding a deep understanding of computer architecture and hardware intricacies. Code written in low-level languages may sacrifice readability on the altar of performance, requiring seasoned practitioners to decipher its cryptic runes. And while low-level languages revel in their mastery over hardware resources, the specter of portability looms large, requiring delicate modifications to traverse the diverse landscape of computing platforms. Let us now embark on a journey through the realms of practical application, where the theoretical constructs of programming language levels find tangible form in the crucible of real-world usage. Firstly, let us cast our gaze upon the myriad applications of high-level languages, where Python, JavaScript, and Ruby emerge as the vanguards of innovation and creativity. In the bustling metropolis of web development, high-level languages reign supreme, offering a fertile ground for the cultivation of digital landscapes. Python, with its serpentine elegance, finds its home in frameworks like Django, while JavaScript, the language of interactivity, powers the dynamic frontiers of React. Meanwhile, the Ruby gem sparkles brightly within the confines of Ruby on Rails, weaving tales of digital enchantment with its elegant syntax and vibrant community. Yet, as we descend into the depths of low-level languages, a different tapestry unfurls before our eyes, a tapestry woven with the threads of efficiency and control. Behold, the realm of device drivers, where C and assembly language stand as sentinels of hardware interaction, wielding the power of direct manipulation with a deft touch. Here, within the bowels of the operating system, low-level languages find their true calling, orchestrating the dance of electrons with precision and finesse. Linux, with its C-based core, stands as a testament to the enduring legacy of low-level languages in the realm of operating system development, while Windows, with its blend of C and C++, embodies the marriage of performance and pragmatism. As we stand at the precipice of language selection, the weight of choice hangs heavy upon our shoulders. Let us navigate the labyrinth of considerations, and chart a course towards the language that best suits our needs. Firstly, we must heed the clarion call of application requirements, a beacon guiding us towards the shores of functionality performance. Consider the specific demands of the application, whether it be the siren song of performance, the allure of scalability, or the imperative of platform compatibility. Choose a language that aligns harmoniously with the objectives and constraints of the project, lest we find ourselves adrift in a sea of mismatched expectations. Next, let us turn our gaze inward, towards the crucible of developer expertise, a forge where skills are honed and mastery is forged. Evaluate the proficiency of the development team in various programming languages, and weigh the merits of familiarity against the allure of novelty. Choose a language that the team is proficient in or willing to learn, for in the crucible of long-term maintenance and support, familiarity breeds efficiency. Yet, as we embark on this odyssey of choice, let us not forget the specter of performance, a silent guardian that lurks in the shadows of execution. Assess the performance requirements of the application, whether it be the need for speed, the for memory, or the thirst for scalability. Choose a language that offers the requisite performance characteristics, striking a delicate balance between development time and computational resources. And as we navigate the tumultuous seas of platform compatibility, let us heed the wisdom of foresight, a lantern guiding us through the mists of uncertainty. Consider the myriad platforms on which the application may tread, whether it be the rocky shoals of operating systems or the shifting sands of hardware architectures. Choose a language that supports the desired platforms with steadfast loyalty, ensuring a smooth passage through the trials of deployment and maintenance. Finally, let us pay homage to the vibrant tapestry of community and ecosystem, a verdant garden where ideas flourish and innovation thrives. Evaluate the richness of libraries, the diversity of frameworks, and the vibrancy of developer communities for the chosen language. Choose a language that boasts a robust ecosystem and a supportive community, crucible of development and troubleshooting. Collaboration is the key to success. As we embark on this journey of choice, may we navigate with wisdom and discernment, for in the world of programming, the language we choose shapes the destiny of our creations. As we gaze into the crystal ball of programming language evolution, we discern the shifting tides of innovation and adaptation. Let us explore the trends that shape the landscape of code in the digital age. Firstly, we witness the ascent of domain-specific languages, DSLs, bespoke tools crafted to carve out niches of specialization in the vast expanse of programming. These DSLs, tailored to specific application domains, offer a tapestry of specialized features and abstractions, unlocking the potential for innovation and efficiency. From the hallowed halls of SQL for database querying to the vibrant realms of HTML/CSS for web development, and the epic depths of TensorFlow for machine learning, DSLs shape the digital landscape with precision and purpose. Yet, amidst the tide of specialization, we discern the rising tide of functional programming paradigms, a beacon of clarity and elegance in the tumultuous sea of code. Functional programming languages and concepts, with their emphasis on immutability, higher-order functions, and declarative syntax, find their place in the annals of mainstream languages. As the demand for robust, scalable systems grows, so too does the adoption of languages and frameworks that facilitate concurrency and parallelism. In the crucible of multi-core processors and systems, languages like Go and Erlang emerge as stalwart guardians of concurrency and parallel programming, offering a lifeline in the tumultuous waters of computation. And as we gaze upon the ever-evolving landscape of programming, we witness the continued evolution of established languages, Python, JavaScript, Java, and their breadth adapting to meet the changing demands of software development. With each update and release, these languages reflect the shifting sands of trends and demands, embodying the spirit of innovation and adaptation that defines the digital age. Thank you for your unwavering attention throughout this journey.